All right, ladies and gentlemen, now we're time for projectiles that change position both horizontally and vertically. So let's talk about projectiles that are thrown straight out. With projectiles like that, they begin with only a velocity in the horizontal direction. But they do have a velocity in the horizontal direction. So they will begin with a velocity in the x direction, but the velocity in the y direction will be 0 because they're not thrown up or down. They're just thrown straight out. So we will use both of these pieces of information, these series of equations. And your first task on each part of a problem is to determine, am I dealing with something that's happening up and down right now, or am I dealing with something that's happening side to side right now? Which part of the problem do you need to solve? So let's start with this one. You should have a paper that looks like this. A boy throws a ball straight out at a velocity of 40 meters per second. If the ball hits the valley floor 2 seconds later, how tall is the cliff? Hopefully you've become pretty good at this. Let's back up though and let's look at what we're looking for on this problem. How tall is the cliff? That will be vertical information. So in order to figure this problem out, we can collect the vertical information. I have a velocity right here, but this is a velocity because the ball is thrown straight out. This is a velocity of 40 meters per second in the x direction. So the fact that the ball is thrown straight out at 40 meters per second will have nothing to do with how quickly it falls toward the earth. So this problem will be just like a problem where the boy had dropped the ball straight down. So let's proceed with that in mind. So I'm going to start with a velocity in the y direction of 0, and I'm going to start with my starting position as 0. Down is negative. So in this case, I have two pieces of known information that are 0, the starting position and the starting velocity in the y direction, and I know it takes 2 seconds for the ball to strike the floor. And I'm looking for the position in the vertical direction at t equals 2 seconds. This equation is the one that's going to help me, and as when we've used it before, this is 0 and this is 0, so essentially I'm just dealing with the final position is 1/2 gt squared. So when I drop that information in, this all goes away, and I take 1/2 times negative 10 meters per second squared times 2 seconds squared, and I find that I multiply 1/2 times negative 10, and I get negative 5. If I square 2 seconds, I get 4 seconds squared. So I multiply negative 5 meters per second squared times 4 seconds squared, and the answer is negative 45 meters. So I know that the ball falls 45 meters in 2 seconds. So the change in position vertically in 2 seconds is 45 meters.